Hi there, and welcome to this Tech Week 2022 talk on engineering productivity, releasing your team's handbrake. My name is Myles. I'm the co-founder of Wires Uncrossed, and before that I was the GM of engineering at Xero, working and leading the engineering teams behind a lot of the services for small business owners in their cloud accounting platform. Before that, I was the CTO of a company called Accordo, and that focused on software asset management, and then later went on to do cloud optimization, what's now called FinOps, I suppose. I'm also a member of the serverless community in New Zealand and over in Australia, and an engineer and a sailor. I don't do as much sailing as I would like to these days. Quick shout out to our sponsors here today. First of all, the Grid Auckland. It is just fantastic to be out engaging with the community again. Although ironically, if you're watching this, we've recorded it ahead of time, but we will also be in Auckland later on today. And it's just fantastic to be in person after a long time. And thanks once again to the Grid for their continued community support. Also, shout out to Wires Uncrossed. We've been running for just over 3 years now, and we're here to help technical teams connect. We do that based on a foundation of communications and change management for technical and engineering teams. And now we also run a software engineering practice on top of that for capability uplift. Cool. So, okay. In its essence, engineering productivity is about, for any software engineering team, be it a startup or a scaling team or an enterprise, how can we actually maximize the amount of time that team spends on customer value and minimize the amount of time that's frankly almost wasted on avoidable engineering problems. But we just can't see that waste so much because we work in an intangible type of system. We're going to step through the quick history of it, then we'll also talk about how to snapshot your own delivery system, and then once you've got that insight or the size of the prize, how can you actually get started with engineering productivity, and then also cover off some traps and just have a summary of what we went through. So as we get into this, one thing just to clear up is what we're going to be talking about and not talking about, and there is a rich history of product development and software engineering, and depending on the size of the organization, sometimes these disciplines are actually the same, or sometimes they actually grow to be more distinct as the organization grows. But if product is the focus of ensuring that we're always building the right thing, then engineering is the focus of how do we ensure that we're building that thing right, and then we're united, or there is a healthy culture of continuous improvement that unites the two. Like I say, if it's a small team, probably they're all the same discipline. If it's a larger team or a team of teams, they sort of start to grow as the accountabilities of, say, commercials for product and reliability for engineering, as those sort of get a bit more significant. Okay, so a quick history of software engineering, really. So where to start? Well, recent talk at Xero reminded me that really it goes back to Ada Lovelace, which is widely referenced as the first person to actually write a real computer program, although the machine to run it on didn't actually exist. So good old Ada, she measured her lead time for changes in decades as opposed to hours or minutes. But anyway, if we sort of just recap, so programmers were around in the 1960s and onwards. A lot of them sort of came out of academic fields or specific actual engineering situations, and it was often they were optimizing very much for the hardware, and so it was often a specific task to run on a specific machine to achieve a certain job. Then if we go on to the 1990s, there was an explosion in computer science courses around the world. And so I joined the realm of computer science in 1998 in Dublin. And at that stage, Ireland and many other countries were actually just producing a huge amount of computer graduates. It was very much focused on the hardware. We were all working on desktops, so that had improved to a large extent. We were struggling with connectivity. I sent my first email around that time to my sister. And I also remember spending almost an entire holiday weekend trying to download the Java development kit. It took like 72 hours or so over a dial-up connection. But anyway, so we moved on to the software industry is quite large at this stage, but we're sort of publishing software, and you print it and you hand it out to somebody, and then you deal with the consequences or any bugs with it thereafter. Then around that time, about 2005 or so, we went on to this mode of MVP and an awful lot of focus on agile development. The book of the Lean Startup was published around that time, and also Facebook started back in about 2004, just to give you some context. So Eric Ries's book, The Lean Startup, that sort of started to codify the MVP, or minimum viable product situation. And that sort of, the industry kind of took that and poured fuel on it. And this culture of sort of move fast and break stuff started to creep in. It's just like money wasn't the problem. There was lots of ideas around. So just keep going fast, and you can fix it up later. And then if we go on to about 2013, then things started to actually shift a bit. And it was probably in response to this move stuff fast and break stuff. But the DevOps scene actually started to come to life around this time. And the mantra moved on to you build it, you own it, which is a good idea because the expectations of customers had actually started to increase. So around 2014, a very popular, influential book, The Phoenix Project, came out, which many of you have probably read. The Phoenix Project was in turn inspired by another book called Flow, which was very influential at places like Amazon, about how do we actually look for constraints in the system and tackle those constraints systematically. So this was about the same time that I actually started looking at engineering productivity, although I didn't know it was called that back then. By this time, I was working as the director of engineering at a company called Finally, who works on HR tech. And it was one night around that time, I got that phone call in the middle of the night, like say 2 a.m., 3 a.m. I looked at the phone bleary-eyed, and it was my boss. So never good to get those calls. Kind of knew what was coming. Answered the phone. They said, Myles, you gotta wake up and log in, and then call us back when you're in. And so it was in the middle of one of those incidents where the west coast of the States was awake, but New Zealand was asleep. Our systems were down, and from about 2 a.m. up until about almost 6 a.m., we were going through all sorts of ways of trying to actually get our deployments working again. There was a big fleet of virtual machines, over 100, I'd imagine, at the time, and they were all maxed out, and we couldn't actually swap them around. There was supposed to be a cloud service where we could sort of hot swap one deployment for another, but it just wasn't allowing us to do it. The machines were just locked. So we were onto our cloud provider. This is all the way through this morning. And eventually we had to resort to doing a fresh new deployment in a whole other region. It was the first time we did it, and we had to do it on the fly. But finally, the system came back up and running, and we were none the wiser as to what actually happened. We eventually figured it out that some weeks, some months later, that it was actually a regular expression problem, that there was a vulnerability where somebody would put into a certain type of search, and it would actually just max out all of the servers. Anyway, I went into work the following morning, and I was just anticipating a tough couple of days in response. The psychological safety thing would have been challenging at the time. And so how are we actually going to get back to our customer support team and our customers themselves as to explain what happened and how we're going to avoid it happening in the future? And as I was in the office that morning, I was also actually just looking at a spreadsheet of our costs. And so I had our cloud costs. We were spending well over $1 million a year on those servers that we just couldn't wrangle the night before. And also we were spending tens of millions of dollars on the wage bill. And I took a step back, and just in a moment, it sort of came to me that this is absolutely, it's bonkers what we're doing, that we're spending too much time on trying to become experts, in that case on the cloud and virtual machines and so forth. And we were not really using the talented team of programmers that we had in front of us, we were asking too much of them, and so something's got to give. And from that moment onwards, I have focused all of my work and my career and my positions on how to actually optimize for the people as opposed to the hardware. And alongside this time, I didn't know it, but the DORA research program had also started. I'll explain more about it shortly. But DORA has been a gift to the industry. It's been quietly gaining insights and credibility since 2015. And in terms of, just to wrap it up there, if I thought the expectations of our sales team and our customers was high back in 2015, then it's just continued to do that. So as we've evolved these different ways of doing software engineering, the expectations of our customers and our users has continued to meet. And so we actually really need to optimize for what are we spending our engineers' time on, because there's a lot of expectations for them to meet. And as a case in point, last week, you can imagine what it was like for the team behind Roblox when it was off for 11 hours and there was maybe somewhere in the region of 210 million teenagers upset that they couldn't use their thing. And so although that's a game and not any life-threatening situation, you can imagine the similar amount of expectations that happen on some of our more line of business applications or even our public cloud providers. And what we're going to talk about is how teams behind very large systems have learned to manage their productivity and how we can apply it locally. Back to the DORA program. So the DORA really is a long-running or a longitudinal study of software delivery. And it's, I guess, the punchline to take away from it as an organization is that compared to low performers, if organizations that have the highest level of software delivery performance, that they're twice as likely to exceed their goals. And the beauty about the DORA program and the book Accelerate, which captures the research, is that it's not hypotheses. It's look back and study and see what these organizations, what have they achieved, and look at the practices that they actually use, and then look for the actual correlations between them. But yeah, if it's new to you, I strongly recommend either read the book, or if you go to devopsresearch.com, there's a pretty good website to actually get you up to speed on it. So when we talk about the DORA program, the real gift of the DORA program is that it started to produce these metrics. Originally, it was just the metrics on the left, the software delivery performance. And now the latest version sort of reflects what the resilience engineering community has been telling us, is that it's not just about how reliably you can send changes out the door, but you also have to balance that with measuring how well those systems are actually surviving in the wild. There's four numbers. On the left are the lead time for changes. So that is how long. Lead time can get confusing, but this one is how long from when you commit a change to the code base to that change actually making it out into the production environment. So it's a deployment as opposed to a release. So you can hide things with feature flags, but regardless, if you make a change, push that change, how quickly until it gets into the customer's environment, yes. Next one is deployment frequency. So how often do you do those changes? Then you go on to the other side, is about the confidence of those changes. So if something bad happens with one of those changes, how quickly can we actually stop the problem happening? How long can we restore the service to an operational state? And how often does that happen? So the change failure rate. So how often are we actually having to roll back or restore changes or respond or fail forward? And then, like I said, the other thing, the other balancing act that we have to keep an eye on is that reliability aspect of it. In terms of which ones to measure, we can go into this in a bit more detail later, but the lead time for changes in deployment frequency, they're quite valuable and they're good to start checking in on measuring regularly. The next two about change failure rate and time to restore services, they're quite valuable initially in helping run like a return on investment calculation. However, they can be problematic to actually measure long term. We'll come up with ways to get better at it. But if you start measuring the change failure rate, then it has a connotation that engineering teams may actually not raise incidents as early or as often as they should. And also the time to restore service. That's incredibly subjective about when did the problem happen, when did we stop it happening versus when did we clean up any remediation work that might have happened. And so what you're actually much better off doing is, if you are going to implement any measuring system systematically, then focus on the lead time and deployment frequency, and then also the reliability, and then only then come back to others if you need to. Cool. So we have these metrics. However, what's good? What does fast actually look like? And so here this table explains it, but for simplicity's sake, if you just go over to the high column or the elite column, the deployment frequency, teams in that area, they can deploy whenever they want. So it's mid ones would be daily or weekly, but an elite team it's not uncommon for the ones that we've worked with that they would deploy multiple times a day. Lead time for changes is less than an hour, and I've actually seen that come down to almost 6 minutes with some of our teams at 0, and also elsewhere. So these are like small discrete services. That's the trick to it. And so if you push out the change, you can get it going out there in maybe in minutes, but at least less than an hour. Time to recovery, like I said, usually that's less than an hour. The only way you can do that is just put the system back into an operational state, but that wouldn't necessarily cover the time to actually clean up any data corruption or something that may have happened. And then the failure rate is, the bar is at less than 5%. So out of 100 changes, only 5 of them cause you to actually jump in and do some sort of remediation work. And that is the real gold, because until we had these numbers, measuring software delivery was, well, it was avoided, frankly. So we had things like story points, and rightly people say don't measure story points, be careful not to compare teams and everything. However, what Accelerate and the DORA program have shown is just they're the facts. There is a certain level of performance that elite teams who are highly successful, and they operate at these levels, and then there is also a huge midfield that operates at a certain level down, and then they're coming up the rear. So that was the gift, and companies like Wires Uncrossed, it's our mission to move as many people from low to mid and as many people from mid up to high. That's what we get our energy from. So you look at those numbers just as a snapshot, but you actually have to look at it over time to understand the real impact of moving faster. And so this chart is comparing the different grades of performance just using the deployment frequency. So we're not even factoring in how much time you might save from not having so many incidents or having quicker recovery times for it. But this is, if you look at the area under the curve, is probably the most important one at the bottom graph. That those elite teams, by the time over a 52-week period, they've deployed over 1,100 times. And the interesting thing is the network effect. So obviously that's a lot more deployments. But if they've done that many, those teams, there's the culture in those teams, or the DevOps culture in those teams, is very much more focused on the customer and the value proposition. Because they deploy so often, there just isn't really any talk about it. It's a rarity whenever there's any discussion about the actual DevOps underneath, or the mechanisms. And also, to deploy that many times means the ridiculous amount of automation has to be put in place to actually maintain it and do it consistently. And that same automation can be used not just for feature stuff, but also in responding to changes or threats, be it like an incident or a security vulnerability or a compliance thing. Pretty much everything has to be as code. Every change has to be as code in these situations. And so the team not only gets the benefit of more customer value being shipped, but also gets a lot less interruptions or a lot less impact from having to respond to other things in their environment. Okay, a quick thing on measurement. I'm going to skip that. And I'm on 20 minutes already. But I'll keep going. So measurement and software systems, traditionally, like I say, it has been avoided. However, we do need to measure things, be it either COVID case numbers or software delivery. We need to measure so that we can prioritize our resources, so that we can validate our actions and stay motivated. There was a talk back in 2018 by Josh Robb from PushPay on tension metrics, and I'll just put the link in the comments. But that taught me an awful lot about how to treat metrics with software teams and do's and don'ts. So now coming on to DevOps, so we have our traditional DevOps loop and how it relates to productivity. And DevOps is an awful lot about the how we do stuff around how does our delivery pipeline efficiently build, test, and release code changes to customers. And then also the feedback loop of monitoring and then planning, reacting, learning from what we're observing in the wild, and then putting it into the planning system and working back. So that's all a great idea and awesome, and it's a first-class citizen. It's just it can get overwhelming. And so where engineering productivity comes in is how do we actually guide DevOps initiatives? And so you can, if you say DevOps, it can be a triggering comment or a triggering word for some people. It can mean a lot of things. Some people get wrapped up in the tooling, and then others get wrapped up in the process, in the philosophies and the cultural aspect. But what productivity does is it's almost like an orchestration layer across DevOps. So if it's got engineering productivity also has the pillars of not just efficiently sending out the code, but also how reliable are we making our systems, and then in turn job satisfaction, with the idea that they all inform each other in a positive loop. So engineering productivity, you can think of it, as a guide to DevOps. Okay, with that in mind, let's take a look at how you can snapshot your own system. I'm going to say system a lot as opposed to a team or a component, because in this industry, as we've all slowly realized over time, it's a mishmash of not just technology, but also technology, processes, and people. And it all has to work together along with the little things like culture for it to actually stay in a healthy state. First thing to do with understanding your delivery system, there is a thing called the quick check on DevOps research site. You can go ahead just in your own time and actually just answer a couple of quick questions, and you will get a feedback loop as to where you're actually plotted on the system. It takes into account also what industry that you're in. So you go ahead and do that. When you do it, don't just cherry pick things. So sometimes when people go and do their self-assessment, they'll pick maybe like a service or a component that they are quite proud of. However, you might be sort of missing the trick with that one. And we all have to take a spread of which ones. So take the fast one, but also then take the slow one, or the one that people are sort of whenever you talk about modernizing it, everybody sort of sucks their teeth or it looks like the ground. So you kind of need to balance things out, because you have to reflect what systems the teams are actually going to be regularly running on, and they're the ones that we have to optimize. And so when you get your results, you will, some of them might be right up at the elite performance levels and other ones might not. And that's where you have to start thinking about yourself, or asking about wherever the gap is, then glass half full or glass half empty. Is this opportunity or is it waste that we have in our system? This is an example. So when you do that, this is an example from one of our teams in New York, where they made a dashboard to track it over time, but they got their delivery lead time down to an average of 37 hours, which was actually a huge improvement. They started off, that was the result of 18 months of focusing on test automation and reworking about the stages about how they did their delivery. And so that focus on testing eventually made a huge reduction down to 37 hours. It was up at like weeks and months in some cases. But also it shows the problem of the risk with averages and measuring them. So some of those components, you probably can't read it, but some of them go down in maybe a lead time of say 3 hours. And then also there's one in there that's still at 139 hours. And so if the team is going to optimize anything else, there's no point in squeezing more juice out of the fast ones. We really need to figure out, of that 139 hours, in that case, it was a monolith that the team have to depend on. That's the real constraint. And sometimes that team is in a position to influence that, and other times it has to escalate to a wider conversation with other teams as to how we can move forward. But don't overcomplicate this bit. Data spreadsheet or a data dashboard, you don't need a dashboard. You can just do it in a spreadsheet just to start getting a feel for it. Also have the conversation about your delivery system. Be pragmatic about what we're actually optimizing for. So a startup might be really optimizing for trying to get that market fit or time to market, and reliability or compliance may not be as much of a thing because maybe they don't actually have a whole lot of load on the system. However, there is merit in actually having that conversation in an informed manner and kind of just drawing down like your trade-off sliders as to what we're actually going for. Also, in terms of what's our maturity, so we do this systematically when we engage with teams, but where do we actually rank ourselves on various disciplines like test-driven development or feature toggling or reliability, observability, that sort of thing. So then you've had the conversation about, you've plotted yourself on the map and you've had the conversation of where we are at maturity. The real goal of what you're going after now is to find your system constraints. And this can take a long time. However, frankly, you can shake out the really big ones quite quickly by just asking the right questions. So if you sit down with the team and you challenge yourself about, you've got a system here today, it's taking, I don't know, maybe a week on average for changes to get deployed. If we were to challenge ourselves that those changes have to get deployed in 10 minutes, like really go beyond what you think is possible currently, then what comes to mind? What things need to be true for that to be okay and for us to be confident and comfortable in doing a 10-minute delivery? Also, what if we actually have to repeat that every day? So how do you have to make it sustainable? And then if you get to that level of constraints, then something will still go wrong. And so what needs to be true for the team to actually be the first one to know about the failures, as opposed to the customer contacting support and then you get egg on face and so forth. And how can we actually, if a failure happens, what do we need in place to be able to recover from that failure in minutes? So that'll start to shake out a lot of things about your delivery constraints. Testing is always in there. I'll talk about that in a while. That's almost always some level of the quality controls that you put in place. And then also some safety nets that you have out there, like rollbacks, partial deployments, feature flagging, that sort of thing. Next one is the identifying the limits. So this sounds similar as being confident about making the change, but also we have to know that even if we built the system today and deployed 20 services today, they won't remain in a stable state. So things change. The amount of load on them sort of grows over time. Dependencies change. And so we need to also identify the limits that the system is operating under as best as we can. And again, quickly, a couple quick questions we'll go through. Do we know our load limits? Have we actually tested it? Do we know, have we taken it to the point of breaking? Do we know our sales targets? Like if the sales team are successful in even half of what they're going after this year, or maybe even double of what they're going this year, will that match up with those limits, or are we actually sort of approaching the line? And so will we actually know if we're approaching the limits of the system as it is today? And then lastly, how prepared are we for a major incident? So if something bad was to happen, so think of your doomsday scenario, or maybe even a more likely type scenario, what would actually happen if that came to pass, be it a key dependency or a hack or something like that? How prepared are we for the major incident? And then you'll have enough information at this point to actually run your return on investment calculation. There is a white paper that you can get from Google Cloud on the ROI of DevOps transformation. Just a word of caution on it. It's sort of set up for very large companies. I think they're small to medium companies, have an average annual revenue of 100 million or something. So it's a kind of a global scale. So you'd have to reality check it for the size of organizations that you're working with. However, generally the ROI conversation will have to be had, because if we want to speed up the system, we often have to slow the system down while we do that. So slow down to speed up. And so hence the return on investment conversation will come up. But keep it simple. So generally speaking, if you're going to, the cost of unnecessary rework avoided by year, so on how much waste we're going to take out of it, is you take the team size, multiply it by their salary, or their actual true cost of each employee, and then you multiply it by the percentage of time spent on unnecessary rework. And you can get those then from that change failure rate and time to recovery type figures, which you can guesstimate if you don't have an accurate figure on it. So that's on the getting rid of the waste. And then on the opportunity side, it's the potential return from investment is how much time we've actually recovered and given back to the team to invest in new features, multiplied by the amount of revenue those features generate. I'm oversimplifying it, but again, I wouldn't recommend complicating it. Put it in a spreadsheet and you will get an approximate feel for the size of the prize. And then you have all of this insight and information, and it'll be time for action. So with all of that information, you will have it, there will be some excitement, and we should do this and we should do that. However, nothing will really happen unless it is somebody's job to actually work on the system. And so sometimes that means actually getting help. But this sounds pretty basic. If you think of an engineering team, who's actually accountable for the productivity and the capability and the quality? Usually it's the engineering leader and or maybe a combined product leader at the top, but we also have to think, have we made that expectation clear to individual engineers that it's not just about working in the system, we also have to work on the system. These days, medium to large companies, they'll have roles like principal engineers, or in larger organizations like Xero, you'll have like an engineering experience division, and that's what the other big tech companies have as well, be it engineering experience, developer experience, engineering productivity. And they also deploy things like the team topologies, which is a great piece of analysis. If you haven't come across it, it's a really good book as well. But combined with, is it somebody's job? Is it clear the accountabilities and responsibilities of improving the system? And then you've got these plays like team topologies around platform teams who are supposed to just make pain go away and become a self-service solution for something like your compute or your deployments. Is it time that we put a complicated subsystem team around some core piece of our thing, often things like the billing engine or something like that, or the core brains of your product or platform? Put a team around that and they'll handle the level of complexity within that to make it easier for other teams to consume. And enabling teams, they are actually super powerful, and the people from Team Topologies, they have a new book coming out specifically on enabling teams, on the patterns and anti-patterns. It's well worth a read when you see it. And then finally, the enabling teams are usually temporary in nature. So you form that team to move a problem from A to B, and then they will step away, and afterwards those stream-aligned teams, or those feature teams or product teams that they're serving, those stream-aligned teams have become more independent as a result of the enabling teams engagement. So you're always trying to make your stream-aligned or your feature teams as independent as possible and maximizing flow through their systems. So when you find a constraint, maybe tackle an enabling team across it, and that the outcome of that enabling team is the problem is gone, or they've matured the platform team to an extent that the problem is mitigated. When you're doing all of this, the key message though is to get help. So often this can seem a bit intimidating. That's where companies like Wires Uncrossed Engineering, we specialize in coming in and helping with certain aspects of this, because it can be a bit intimidating to start. Starting is the hardest part. Once you're moving, it does actually tend to feed itself. And on that, so sometimes change does actually need a nudge. And so there are the actual long-term plays that we do for improving the system. The first one is, we call it the Corolla effect. But Toyota Corolla, launched in the 1960s, became the most popular selling car for many decades. I'm not sure if it still is, but certainly up until about 5 years ago, it was the most popular selling car in the world. And they become the poster child for continuous improvement and things like the kata model, where you have a series of small improvements. And that's actually a way more powerful in the long run than any big bang program of transformation. So whatever's your poison, OKRs, or goal settings, just have some system that you can put continuous improvements goals into it. And then you give the teams the expectation and empowerment to actually go and make those improvements. And you reward them. So this is a lot more about culture than anything else. So you end up with a system of continuous improvement where we balance not just the feature that we sent out to customers, but also the small micro gains, because that stuff is real gold in the long run. Read up more on that on things like the kata framework, also Atomic Habits, the book by James Clear. He speaks about it also. So continuous improvement, that's like table stakes. We need something like that in whatever you call it in your organization. It's just, and then we sort of put stuff in the hopper. However, sometimes that's not quite enough to get it going. And that's where some more deliberate or forcing tactics actually come into play. The first one of these, or more deliberate approaches, is I didn't realize it until last week talking with a team at AWS, but they refer to it as the New York approach. And we said, what? And he said, yeah, the New York. If you can make it here, you can make it anywhere. And this is where you actually deliberately you do your sweep, you find your constraints, and some of them might be a bit intimidating or large or scary for the team. And they're actually the ones that you deliberately choose to go into. So you find the system that is most intimidating, and you say, we're going to modernize that piece, or we're going to refactor it, or we're going to improve its reliability or productivity from A to B. And if you do that, then you've sort of broken the myth, bust the myths for all the other people that are downstream. So this might be in Amazon's case, it was their billing system. So everybody said that thing is too big, too important, can't slow it down. And so when Amazon were moving to their service-oriented architecture, they deliberately targeted that system. And then when they went on to any other group, the case was already made. Well, yes, sure, you have your own complications and situations, but you're not as complicated as that one. We've used it as well. So at Accordo, we used this for we had to run essentially like a calculation engine. Everybody said it couldn't be done. And so we deliberately targeted the calculation engine, and we were determined to make it be as small and as efficient as possible, because it was going to be actually the core crux of it. And we succeeded, and then everybody can then just point to that. The team has then the confidence, well, if we can do it for that, then we can do it for all of these other, say, CRUD operations. So, yeah, prove it with the biggest challenge. Next one is what's sometimes referred to as burning the ships. So this one is controversial, but I have seen it actually used, and that's what removes the choice of actually going backwards. This is most popular when you're dealing with teams who are maybe having to actually migrate to the cloud for the first time. In Accordo, we had a similar one of these around the event of GDPR. So GDPR was launching, and we had a lot of on-premise database infrastructure. And we kind of used that as a forcing function, that the only way we could actually achieve GDPR compliance and all of the other privacy regulations was to actually get the database systems onto Azure. Everybody was quite, I guess, anxious about it, because you're talking very large databases that had been growing on-prem, as it were, although in an Oakland data center. A lot of customizations and voodoo around the databases, but we actually had to make it happen, and you remove the choice. I've also seen this happen with office moves. So if a company is moving from A to B, they just say, oh, well, we're not going to take the hardware with us, and so it's going to force us to move. So yeah, remove the choice of going backwards. Controversial. You need a lot of sponsorship and maybe some outside help as a plan B to de-risk this strategy. And then the third one that we've had a lot of success with since that 2015 type period is going serverless first. So look for any opportunities you can to actually leapfrog, moving from, say, a current virtual machine situation onto a serverless one. And the reason we do that, the reason we've had a lot of success with it, is that it's a lot easier to go serverless first and then to let that serverless system, if it needs to actually mature up or expand up into a more complicated thing like containerization. But it's a lot harder if you just try to go from virtual machine to containers to serverless. You'll probably never get there. You just end up sort of coping with a level of detail around the compute layer or the database layer or the web delivery layer. And just to sort of iterate that, the skip ahead thing, this is the cloud native landscape. And so up in the top left is the serverless frameworks and tooling and so forth. And then the one down at the bottom is the one on Kubernetes. So if I was to talk to you a couple of years ago, I would say, yes, serverless for everything, but there is a need to actually go beyond serverless if you've heavy workloads, intense above certain levels and so forth. However, most companies, most systems in most companies are not actually at that level. They will have a few core services that are intense traffic and high availability required and so forth. And other ones, it's actually more like tumbleweed when you analyze what real work they're doing over a 24-hour period. So yes, skip ahead if you can at all, because if you just follow what seems like the easiest path of migrating onto a different type of compute system, you might be leaving a lot of money on the table. And when I think of some of the database solutions or some of the compute solutions that teams end up doing on the modernization stuff, they've ended up just putting too much horsepower on it. So like it's using an excavator to crack an egg, but there is actually a much more efficient way to do it. And the amount of services, let's not forget, the amount of services and components is always increasing. And so if you run, say, just decide that we're going to use compute solution X for everything, then that generates a lot of tax in the long run when you're running hundreds and hundreds of services. If you want to iterate on that solution, it gets harder. Cool, so that leads us into some traps and summary of where we got to. So this first one is analysis paralysis. So DevOps can be overwhelming, and the DORA research program and the capabilities that they highlight, that PDF, you can get it on the website. It shows all the relationships and intertwined across particular toolings, architectures, technologies. And what we see with some teams is that it gets all a bit too hard, and we sort of focus on some Narnia state or some Nirvana state, should I say, that if we re-architect everything and move this onto that, then we will get the maximum return on investment. However, you kind of need some level of pragmatism. And then Peter Blake used the old saying about, will it make the boat go faster, when he was leading the New Zealand America's Cup team back in '95 and 2000. And so there was a high impetus for action. So you just keep moving forward. So even if you're not going to get the maximum return on investment, do favor action and actually making a decision to move yourself and the team forward. And just use that. You've got your constraints known at this point, you know about your limits. And so use that terminology or that phrasing about how will decision X help the boat go faster or safer to that point. This is also things like templates. So as soon as possible, start codifying your templates. Usually teams end up with a template for their front-end application, another one for their standard API endpoint, and another one maybe for like a worker type thing. Get those into a template form, and then if there's any debate about tabs versus spaces or linting or any of those other type choices that teams debate sometimes, ask them about, is this a good conversation to have? Like, will this choice make the boat go faster? But also just put that little bit of friction in, that if they want to change about how they do a certain piece of their delivery system, it's a change request or a pull request, and they got to kind of form up that in systems thinking. Next one, so this is almost I would say always a trap. So if we go working with a team, at somewhere in that, the quality assurance and quality control conversation comes up. So even if they're pretty good performing, doing multiple deploys a week, if they want to go to, say, multiple deploys a day or like a 10-30 minute lead time, then the conversation comes up about where are their quality controls and what's their quality assurance. And so my actually for early career was in the electronics manufacturing industry, and that's where I keep going back to when this topic comes up. Because in electronics, and a lot of manufacturing, there are two separate disciplines. So quality control are the controls that we have put in place to ensure that we're manufacturing to a certain level. And then quality assurance is the thing that wraps around either end of those controls to ensure that those controls are actually still effective and maintained. And so the hot topic is often if there is a manual step in your quality controls, that is really going to kill productivity. But it's not that we don't need those quality assurance people and that mindset. That's actually needed more than ever at either end of the system, more probably the operational end than the design end. And so how do we actually move the quality assurance to the other end of the delivery system, put as much safety in there, and put as much understanding and feedback and visibility into that end of it. But if you're like when you're laying a block wall, the checking if you've put that block in place is part of doing the work. And so on the flip side, engineers just have to embrace the concept that doing the test is part of the job of implementing the feature, and assume that when they're implementing this feature, perhaps no other person might look at it before it gets deployed into production, maybe behind a feature flag, but yeah, maybe nobody's going to look at it. So don't avoid the quality conversation. Lean into that as early as possible if you do have significant manual steps in your regression process. Next one is local optimizations. So it's a bit like it's only natural. This quote from Henry Ford, whether or not he actually made it, I'm not 100% sure, but the concept holds that if he asked his customers what they wanted, they would say a faster horse. And so sometimes if you've got, this is usually in large teams, maybe say over 30, 40 people and upwards, there might be a serious constraint, and so the teams just optimize around local constraints or local limiting, but no one team is actually able to move some systematic thing, like maybe it's a modernization program from a legacy system or some key dependency. This two on the cards right now are with a runtime version. So a lot of core dependencies around the monolith are all at a very outdated runtime version. Whose job is it to actually improve that? And they're the type of things that you can only do the local improvements for so long before your main constraint will move to that big, larger one. And that's where you just need to have that conversation again as a team about what's the return on investment. Let's make a plan to move the bigger constraint or the bigger optimization. And that leads us into the last trap, which is change management. And so regardless of what you do, somewhere along the journey, if you're moving from low to medium or medium to high, you're dealing with change. And change management has this concept, amongst other things, of force field analysis. And so often the engineering teams, I'm guilty of this myself, we're quite eager. Here's all the green reasons why this change is awesome and fantastic and magical things will happen. However, we cannot ignore the forces resisting against that change. And that's where you kind of need your engineers and right through the leadership stack just to have like a one-on-one of change management in their head, because we got to address the concerns of the forces acting against us. If we don't have a plan as to how we're going to address them, then it will stifle the change. So this could be some organizational stuff like the relationship with customer success team or compliance things about trying to deploy every day. It'll trigger up all of these hurdles, but just acknowledge that those hurdles are there and connect with those people. So at the end of the day, the most effective way to manage these changes is to actually build strong connections with those people. So if you've got a change review board that only meets once a month, then get in there and just get down to the actual true real requirements that they actually have, and you will almost always find a middle ground through that suits both. It's just maybe they're working on outdated assumptions or reactions to an environment that is no longer true. And then you also have to demonstrate how you can make things safety, so how you can minimize the risk. Because the reality is organizations do need software teams to be incredibly agile. If there is a vulnerability or some zero-day exploit or some incredible outage, then the organization needs you to fix that as fast as possible. And that is a lot more easier and reliable and routine to do if they're doing it every day. And so it's just down to like a nature of the change. But they do not ignore the things trying to rain in your parade. Instead, engage with them and make a plan. Cool. So in summary, we have talked about, first of all, quickly understanding your own delivery system. So plot your position, talk about what you're actually optimizing for based on the life stage of your organization, and be upfront about that. So, okay, we're going to go more for delivery and less in reliability. Or if you're at the other extreme, you might actually flip it the other way around. If you've reached a significant market share, pump more out energy and choices into reliability, perhaps. Identify your limits, you know your limits, and talk about them regularly. So even if it's at the end of a retro and everything else like that, put something in that process or in that ceremony to talk about the limits. What have we learned this week? And then lastly, the ROI. You can't avoid it. Cash sometimes seems a dirty word or a dirty topic, but engineering teams cost a fortune these days. And so it's only right that we actually have to think like the business or think like a board member about how would you frame up the return on investment conversation. Then we talked about how to actually get started, and getting started is the hardest bit, trust me. Once you're up and running, it does get easier. Be systematic about it in your culture, bust down some myths, show people what's actually possible. Look out for opportunities. Don't waste a crisis. If someone comes your way, sometimes that can be a big catalyst to galvanize momentum behind transformation. Skip ahead, so wherever possible, don't go to the landline, just go straight to mobile, as it were. Look for opportunities to go cloud native, as it were. And lastly, get help. So ensure that as a team that it is clear the accountabilities and responsibilities for improving the delivery system. Look for team topologies to actually deploy to move things forward, and seek outside help from teams like ourselves or others that can help you. It's just, if you get outside help, just try and ensure it's the success of the outside help is that if the team has become more independent afterwards as opposed to dependent. And so that should be your compass to frame up those engagements. And that is almost it. We also have the traps, so watch out for quality control. So lean into the quality conversation early. Analysis paralysis, so do actually sort of move on and make decisions. You won't make it perfect, but make a decision and make it in the spirit of what you're optimizing for. So will it make the boat go faster or safer? Local optimizations, recognize when you've sort of improved as much as you can locally, and then you're actually, now the biggest problem is actually maybe a wider organizational one. Or how do you move that local improvement through things like team topologies out to the rest of the organization? And lastly, cultural change. So this is change, even though we don't really talk about change management for software teams, that is it. And so embrace the forces that will be acting against the change, connect with them, build the relationships, and have that conversation to get into their true actual needs and concerns, as opposed to what might have been just written in documents. That is it from me. I wish you all luck in your journey on engineering productivity. Teams are incredibly valuable, and they can unlock a lot of the world's problems if we just get some stuff out of their way. If we make life more productive, more reliable, and more job satisfactions for those teams, who knows what problems they're going to solve for us in the future. Always happy to talk about this stuff, either online or in person. Thank you for watching. Until the next time.